All right, let's jump into what's called the rational root theorem. This is just going to give us our possible candidates for rational roots of the given function. So what's the function we're dealing with? F of x is equal to negative 2x cubed minus 21x squared plus 16x minus 8. So where do our eyes need to go? Leading term, ending constant. Look at those two parts right there because they are the important pieces of information that we need to work with when finding all possible rational roots to a given function. Okay, your constant, that's typically the number at the end of the function, especially if it's written in standard form, meaning we're going in descending order with our exponents. So that number that doesn't have the variable attached to it, that's what we call a constant. That's going to have to do with our numerator, or numerators, plural, because we're going to have a lot of possible candidates for roots. So every single one of the numerators is going to have to be a factor of negative 8. So what I like to do is just put a negative 8 down, and then I draw a line because I know that there are 4 different factors of negative 8, and I'm going to have to list them out in just a second. The way I'm going to show you how to do this is creating a table. There's a lot of different ways to organize your information. I'm just a huge fan of the table. That's the way I like to show it. That's the way that I do it. Now down here, that line is much shorter than this line because now I'm looking for factors of my leading term. In this case, my leading term's coefficient is negative 2. So I just set negative 2 off to the side right there, and I'm going to have to give factors of negative 2. Now, one thing I know about negative 2 is it's only got 2 factors, right? Positive and negative 1, positive and negative 2. Those are 2 values that get multiplied together to make a negative 2. But when it comes to negative 8, we've got more than just 2 of them. We've got positive and negative 1, positive and negative 2. Negative 8 is also divisible by positive or negative 4, positive and negative 8. So now I've created 1, 2, 3, 4 columns, 1, 2 rows, and I have a table that now I can list out all possible roots to this given function. How do I get them? Well, remember this has to do with our numerator. This has to do with our, I think I forgot to tell you that, denominator. Okay, so all possible factors of negative 8 are listed here. So we're taking these as our top values, our numerators, putting them over 1 over 1, or in this case 1 over 2, and that's what's going to give us our values that go inside here. So let's just break it down with each one of them. We'll go through this fairly quickly. Positive or negative 1 over positive or negative 1 is just going to be positive or negative 1. 1 divided by 1 is 1. Now we're taking a 2 over a 1, so we're going to get positive or negative 2 there. A 4 over a 1, that's going to be positive or negative 4. 8 over 1, you get it. Okay, but now we're taking 1 and putting that value, remember these values are our numerators, these values are our denominators. 1 over 2, so that's positive or negative 1/2. 2 over 2, that's positive or negative 1. 4 over 2, that's positive or negative 2. 8 over 2, that's positive or negative 4. Well, I already got a positive negative 1 there, so no need to copy it down twice. I already got a positive negative there of 2. No need to copy that down twice. And we repeat here as well, so no reason to set that one up either. What's left? These are our possible rational roots to the given function. So what I can say is, what are my possible roots? Rational roots would be positive negative 1, comma, positive negative 2, comma, we're just listing each one of these out right now, positive or negative 4, comma, positive or negative 8. I like my students and myself included, I will typically put them in numerical order. So since positive or negative 1/2 is the smallest value, I would put that one in the front. And then as we get bigger, we put commas in between each potential root to the given function. All right, so if you're asked to find all possible rational roots to this given function, your final answer would be positive and negative 1/2, 1, 2, 4, and 8. Hopefully this makes sense. Study hard, start practicing it, and good luck on your upcoming test.